Hey there, stats enthusiasts. Welcome to another lesson in our AP Statistics series on inference for categorical data proportions. This is Unit 6, and we are currently on Notes 5, where we are going to be talking about Type 1 and Type 2 errors, as well as power of a significance test as it relates to significance test for proportions. We're going to be talking about what these errors and power is exactly. We're going to be talking about the relationship between all of them and how they influence a significance test, as well as talk about interpreting these errors in a context of a problem. This is a favorite lesson of mine, so I'm excited for you to tune in. Let's get right into the content. I always love to start this section of notes with an analogy. So this courtroom analogy is a great way to introduce errors and power into something that a lot of us have already seen before. So in this analogy, we're going to set up the truth and the jury's decision, because whenever you go to court, there's the truth and then there's what the jury decides. So the truth, either you are not guilty or you are guilty, and then the jury decides, are you guilty or are you not guilty? So these are our decisions in the courtroom. So what are the situations here? So if the truth is you are guilty and the jury decides you're guilty, well, that's a correct decision that we like to see, right? Same thing with if you're not guilty and the jury decides you're not guilty. We also love to see that decision. Okay? Ideally, this is how our courtroom and our justice system would work. If you're guilty, the jury decides you're guilty. If you're not guilty, the jury decides you are not guilty. However, there are two possible mistakes that could be made in the courtroom. If the truth is you are not guilty, but the jury decides you are guilty, what happens? Well, that's an error, and an innocent person is going to end up going to jail. Okay? If you are not guilty, but the jury decides you are. So that's one mistake. The other mistake would be if the truth is you are guilty, but the jury decides you are not guilty. What happens there? Well, a guilty person ends up going free. Okay? So in this situation, the truth and the jury's decision, we actually have to make this decision with significance tests. Okay? Now, if I look at these two errors leading into significance tests, if I look at these two errors, what would be considered the quote-unquote worst mistake? Okay? What would be the worst mistake made in this situation? What would be the worst error to make? And this is a conversation we usually have in class, and a lot of students come to the conclusion, it depends on the crime, right? If the crime was shoplifting, right, an innocent person going to jail for shoplifting seems a little bit more extreme than just a guilty shoplifter going free, right? An innocent person going to jail when they didn't shoplift seems a little bit more extreme. Vice versa, if the crime was murder, a guilty person going free for murder seems like the worst mistake than an innocent person going to jail for murder. And of course, that's definitely relative to each situation. And that's kind of what we walk away talking about is the worst mistake totally depends on the context. In this case, the context of the crime. But in a significance test, it's going to depend on the context of the test you were running. Okay. So to continue on, why is this courtroom analogy a good analogy for a significance test? Well, a jury is going to decide whether a defendant is guilty or not guilty. And we decide when we run a significance test if we are going to reject or fail to reject the null hypothesis. Now, notice the language is almost identical. The jury doesn't decide if a person is guilty or innocent. Okay. Just like we don't decide to reject or accept the null. The jury says guilty or not guilty, and we decide whether we reject or fail to reject the null. The other analogy is that the jury will always start with the assumption that the defendant is innocent. Right? You've heard the phrase innocent until proven guilty. And that's what we do in our significance test. We always assume that the claim, the null, is true. And we're trying to find evidence against the claim. Just like a court presents evidence and a decision is made, we present evidence through sample data and we find the p-value, and then we make a decision based on that p-value. So that is why the courtroom analogy is a great way to think about errors and power in a significance test. Now, that's all fine and dandy, but how does that truth jury's decision table lead into significance test? Well, we're going to set it up like this. We're going to set up this table like this. We have some sort of truth about the population, and then we have what our decision as statisticians is. The truth, we can either fail to reject the null or we can reject the null, right? Those are the two decisions we can make, and those are also the two truths about the population. Either we stick with the null or we have evidence for the alternative. Okay. So same thing with our decision. Now notice I'm putting these in very specific boxes here. So I have failed to reject first, and then reject over here. And I have reject first here, and then fail to reject right here. Okay, so it's almost kind of like flipped, and I do that on purpose to set up my errors here. So just like we did with our courtroom analogy, we have two correct decisions and two errors in this table. Okay? One of the correct decisions is when the truth is we should reject the null, that there would be evidence for the alternative, and we decide to reject the null and say, yes, we have convincing evidence of the alternative. This is a correct decision. And in fact, it's so correct, we call this power. And I say so correct, we call it power. But it's called power. It has a special word because this is truly what we are trying to accomplish when we conduct a significance test. We want to be in this area right here. We conduct a test because we suspect that the null hypothesis is not true in some way. So we suspect that we should reject the null. So when we run the test and we do end up deciding to reject the null, we are happy about it, right? So we have a word called power that is used to basically describe how powerful a test is to determine that we can reject the null hypothesis correctly. Okay. Power is a probability. It's given a value between 0 and 1. And we do not calculate this probability in this class, but we are going to talk about what kind of influences it in a little bit. Okay. But that is power. Okay. Correct decision. Right in that situation, that's called power. The other correct decision doesn't have a special word for. The truth is we should fail to reject, and we end up deciding to fail to reject, well, that's a correct decision, but it's not impactful in any way, right? We didn't really find convincing evidence of anything. We did it correctly, but nothing really is exciting about that. So yay for a correct decision, but we don't have anything for that. Now, the other two boxes here, these are where our errors are going to happen. These are where our errors are going to happen. And so what do we label these errors as? Well, we label them as type 1 and type 2. Those are our two errors that can happen in a significance test. Very original, I know. But a type 1 error is when you decide to reject the null hypothesis when the truth is you should have failed to reject the null hypothesis. So you did it incorrectly. Not that your data was flawed in some way or that, your math was wrong, but just due to sampling variability, you decided to reject the null when the truth was you should have failed to reject the null. Okay. So when we talk about an error, whether it's type 1 or type 2, we're not talking about necessarily a mistake in the methodology of this significance test, but just we made an incorrect decision based on the data we had at hand. Type 2 error is when we when we fail to reject the null when we should have rejected the null. Okay. That's a type 2 error. So before we talk about kind of what influences each of these, I want to give you an example of what this looks like. Okay, so we saw the courtroom analogy. Here's another example of these errors in a significance test. So in a significance test, you have your null and alternative. So when you go into a doctor's office and you just go see your doctor, it's always assumed that you are not pregnant until you get a test that tells you otherwise. So we're going to set up our null and alternative. Your null hypothesis is you are not pregnant, right? The alternative is that you are pregnant, right? We found evidence that you are pregnant. So these being our null and alternative, let's talk about those 4 situations. Okay, so I have it written up here just so we kind of remember. Our null is we are not pregnant, and our alternative is you are pregnant. Okay, so the truth, I've kind of simplified it down here. When we talk about the truth, remember we don't say accept the null or accept the alternative. Remember the language we use, fail to reject or reject the null. But I've simplified this table down just to make it a little bit easier to help you remember. The truth is either the null or alternative. Okay, so let's pretend either the null is true or the alternative is true. And you decide either to reject the null in favor of the alternative, or you decide to fail to reject the null, which means that you stick with the null hypothesis. Okay, so our 4 situations. Well, let's start with our correct decision, which we call power here, right? The truth is that you are pregnant, and your doctor decides, hey, you are pregnant, okay? That is a great conclusion. That is a correct decision. We call that power. So the truth, you are pregnant, HA. The decision, you are pregnant, HA. And for our visual learners here, this is what that would look like. The doctor says, you're pregnant, and the person is pregnant. Okay, a correct decision, a power, right? We run, let's say, a pregnancy test trying to determine if we are pregnant. Okay, so think about that. We're trying to run a test to determine, are we pregnant? Okay, so that's the correct decision. The other correct decision, you are not pregnant and your doctor tells you you are not pregnant. Okay, so again, the truth and the decision line up, and that is a correct decision. So the truth is the null, and you decide to go with the null. So we say the truth is you should fail to reject, and you decide to fail to reject. And again, for our visual learners, this might be something that resonates with you, telling this old man that you are not pregnant. Okay, our correct decisions. Maybe you can see where this visual aid is going here. But now we have some errors, right? What are our errors? Well, this is the type 1 error. And it's always, the way I draw these boxes, the type 1 error is always in the upper left box. I draw these boxes on purpose in this way so that my type 1 error is always described in that upper left box. Type 1 error is when the truth is that you are not pregnant, okay, your null hypothesis, but the decision is that you are pregnant. Okay? This is a type 1 error. For our visual learners, this is the error that you have. That poor old man is being told by the doctor that you're pregnant. He is pregnant. Okay. So that is a type 1 error. A type 2 error is kind of vice versa, right? The truth is you are pregnant, but the decision is that you are not pregnant. Okay. So the truth is the alternative, but you decide to fail to reject the null, say that you are not pregnant, and this is what that would look like. Telling the pregnant woman, you are not pregnant. Okay. So why are we doing this? Okay. Why are we talking about these errors? Well, one, because they happen, right? Whenever we make a decision, a black and white decision, fail to reject or to reject, there's always a chance you could do it incorrectly. But more so than that, we set a lot of our parameters in the significance test based on which type of error we want to try to reduce. Okay. So before we get into that, let's talk about what goes into influencing these errors and what goes into influencing these powers. So now I'm going to take that table and I'm actually going to condense it down even more into this little sketch I have off to the left on the screen. So this sketch is one I'm going to tell you to memorize. Okay, even someone like me who understands what type 1, type 2, and power are and the relationships among them, I still like drawing this little sketch to really visualize the relationship between these. So in the sketch, this table that you memorize, the truth goes on top, and we have the null and alternative. Okay, and remember, I say null and alternative, but we have reject or fail to reject. So the null, when I say the null, this would be fail to reject, and the alternative would be to reject. And then over on my decision, I have the alternative listed first and the null listed second. Okay, so again, the word on this is to reject, and the alternate, and then HO would be fail to reject, meaning we stick with the null hypothesis. And then once you got that table set up, you fill in the 4 quadrants with this: error type 1, error type 2, correct decision power, and then I just do like a little check mark. This is supposed to be like a little check mark. Doesn't have a fancy word for it, just check. It's a correct decision. Okay. But this table, memorize this table because it will help us understand the relationships here between type 1, type 2, and power. So type 1 error is when we reject the null incorrectly. So we decide, hey, we're going to reject the null. We have evidence of the alternative, but the truth was we shouldn't have, right? We did it incorrectly. The probability of getting a type 1 error is equal to the significance level. What? Why is it equal to the significance level? Well, remember, the significance level told us how low our p-value had to be. And we said if that p-value was low enough, that means there was a low probability of it occurring. So low that we would say the null was incorrect. Well, just because we have a low probability and it's highly unlikely doesn't mean it's an impossibility. Okay? It does not mean it's an impossibility. The null could be correct. We could still get a sample statistic with that low p-value. It's just very unlikely, which leads to our decision of rejecting the null. Okay, so that is why a type 1 error is equal to the significance level. In symbols, this is what that looks like. The probability of a type 1 error equals alpha, whatever our significance level is. Because remember, our significance level tells us what p-value is considered low enough. Okay, so type 1 error is directly related to significance level. So by increasing a significance level, we increase the probability of making a type 1 error. Decreasing the significance level, we decrease the probability of a type 1 error. Okay. Type 2 error is when we fail to reject the null incorrectly. And I know that kind of sounds weird because there's almost like 2 negatives in that sentence, but using the correct language of significance test, we decide to fail to reject the null when the truth is we should have rejected the null, right? So we decide to fail to reject, but we did it incorrectly. Okay. Now the symbols for this, the probability of a type 2 error is equal to beta. Okay, so that's the Greek symbol for beta. Now, calculating beta is not something we are going to do in AP statistics, okay? Just know that it's represented by the, and I give you that symbol because when it comes to power, we're going to describe the power and as it relates to beta. So power happens when we reject the null correctly, which I said before was almost the whole reason we wanted to run a test, is we are hoping for this conclusion right here. We are hoping we can decide to reject the null hypothesis, and we're hoping we can do that correctly. The probability we reject the null correctly is 1 minus the probability we reject the null incorrectly, okay? Now think about that. That is basically a complement, right? So we talked about this way back in our probability unit. The complement of an event is 1 minus the probability of the event occurring. And that's what power is in relationship to a type 2 error. Power is going to be 1 minus beta, okay, minus the probability we reject the null incorrectly. Okay. Power is not a probability we are going to calculate by hand. In order to calculate it, nowadays we just use statistical software, but power is a probability, and it is going to be something you want to be able to interpret. Okay, it's a probability we reject the null correctly. And because it's a probability and because we want to have it happen, we want a high probability for power. We want that large probability for power. The larger the probability is, the more powerful the test we say it is, the more powerful the test is at determining if there is convincing evidence of the alternative. So let's talk a little bit more about the relationship. So that table is kind of an introduction to these relationships. Let's look at them a little bit more, okay? Type 1 and type 2 have an indirect relationship. As the probability of one increases, the probability of the other decreases. So if you want to increase type 1 error, you decrease type 2, or vice versa, indirect relationship. Our type 1 error is set with our significance level, okay, which we choose before we even run our significance test. The higher our significance level is, the lower our probability of failing to reject becomes, right? So remember this, higher. So if you go from alpha equals 0.05 to 0.10, think of all of those p-values that you just included in your potential to reject, okay? So if your significance level is higher, that means you have more of a chance of rejecting the null. And if you have more of a chance of rejecting the null, you lower the probability of failing to reject the null. And when you have that relationship, those are thinking about, rejecting the null and failing to reject the null. They have an indirect relationship as well when we do those correctly. But doing those incorrectly, our errors, also have an indirect relationship. So increasing our significance level will lower our probability of a type 2 error. Okay. The higher our significance level, okay, like I just said, the more likely we will reject the null. Okay. And it's more likely because our higher significance level has more p-values that will allow you to reject the null. Okay. Now, when you are more likely to reject the null, this also increases the likelihood that you are going to do it incorrectly, as well as correctly, but it increases the likelihood that you're going to do it incorrectly. And because of this relationship, type 1 error and power have a direct relationship. So as the probability of a type 1 error increases, the higher your power of the test becomes. Okay? So remember this, if you increase alpha, because that's really the only thing you're going to have control over at this moment in AP statistics is alpha, okay? As well as your sample size too, but we'll get into that a little bit more in the homework. But if you increase your significance level, you are going to increase your type 1 error. You're going to increase your power, but you are going to decrease your type 2 error, okay? If you decrease your significance level, you decrease your type 1 error, you decrease your power, and you increase the probability of a type 2 error. Okay. Those relationships are the important relationships I want you to walk away knowing and understanding. Okay. Now, we're going to finish with an example. And a big part of this section of material is interpreting errors. It goes back to the question I asked at the beginning, which is the worst crime, right? An innocent person going to jail or a guilty person going free. And when we look at a significance test, we always want to ask, which type of error would we rather have? And it always depends on the problem. For some tests, we want to load type 1 error, but for other tests, we might want to load type 2 error. It just depends. And luckily, because these are indirectly related, we can increase the probability of one and decrease the probability of the other. And this is why being able to interpret errors is going to be a key skill that they're going to test you on the AP exam. And we're going to do an example of this and some interpreting right now. Okay. So let's say a drug manufacturer claims that less than 10% of patients who take its new drug for treating gestational diabetes will experience nausea. Okay, so we're going to stick with a pregnancy theme, apparently. So to test this claim, researchers conduct an experiment at the 5% significance level. What are the null and alternative hypotheses? Now, they claim less than 10% experience nausea. But remember that our claim always has to be equal to, and we're trying to find evidence of the alternative. So our null is equal to 10%, and we're trying to find evidence that it's less than 10%. Okay, we want to test this claim, so we're trying to find evidence for the claim. Okay, so the null and alternative we set up, and then Part B, it says describe a type 1 error and a type 2 error in this setting and explain the consequences of each. So we're going to interpret them in context, and then being able to explain the consequences of each helps determine which one would be kind of worse in the setting that we are in. So whenever they ask you to describe an error, I always want you to write down not only the null and alternative hypotheses if it's not written out for you, but I also want you to write down this little table I told you to memorize, because writing on the table helps you orientate what the truth and decision is in relationship to the errors. Okay, so memorize that table. So describe a type 1 error. In context, type 1, we say less than 10% of patients experience nausea when they really don't. Okay. How did I get that, right? How did I get that context? Well, from my table, I know that type 1 is when we decide the alternative, but the truth is the null. Okay. So we say that less than 10% of patients experience nausea. So we say the alternative when really it's not. Okay. When really they don't. So we say the alternative incorrectly. Okay. So that would be interpreting a type 1 error in context or in this setting. And then it wants us to explain what that consequence is. Now, if they want you to do that on the AP exam, it's really there's a few different options for this, right? Just kind of pick whatever the best option is. Think of the real world, right? If you say less than 10% experience nausea, but you made a mistake, what kind of consequence could that have? Well, if the manufacturer thinks that less than 10% will experience nausea, they'll be like, yay, okay, perfect, we're done. We set out to do what we wanted to do. And they won't do anything to actually fix the medicine because they believe it's okay. They believe that their claim is correct and less than 10% of patients experience nausea. So consequence would be they don't fix the medicine. They think it's okay when it's really not. Okay? Type 2 error. Okay? To explain it in the context, think about what this means. A type 2 error means we decide the null, but the truth is the alternative. So we decide that 10% of patients experience nausea, or not less than 10% of patients experience nausea when they really do. Okay? So that would be our type 2. We say 10% of patients experience nausea when really it is less than 10%. Okay? And the consequence of this, the manufacturer might spend time fixing the drug when they don't need to. When they say, oh my gosh, our claim wasn't correct. Less than 10% of patients don't experience nausea. That is the decision we made. We need to fix this medicine so that it does work. When, because it was an error, it worked the whole time, right? So they didn't need to spend all of the money and the resources to fix it. It was already fixed. Okay? So that would be a consequence. Now, which would be the worst error? That's kind of up to the situation, right? Some people would argue that when they don't do anything to fix it, that would be the worst mistake, okay? Those poor pregnant women. And some people would say, the worst mistake would be spending money, time, and resources when they don't need to. Okay? All depends on the context. Okay, 2 more parts here. Part C. The test has a power of 0.54 to detect that the alternative is true. Explain what the power means in this setting and what is one way we can increase the power. Okay, so the probability, the power, this is a probability, right? 0.54. And power is all about making the correct decision to reject the null when we are supposed to. So we say the probability we find less than 10% of patients experience nausea correctly is 0.54. So the probability we decide the alternative, okay, we reject the null, we found evidence for the alternative correctly, is this probability. And again, this is not something that you have to find by hand. Okay? They would give it to you in a problem and just ask you to interpret it like this is. And then what is one way we can increase it? Well, remember that relationship. To increase power, to increase the probability we will reject the null correctly, we can increase the significance level. Okay? This increases type 1 and this decreases type 2. Know those relationships. Okay? And then D, sort of the same situation. You know that the power of this test at the 5% significance level is 0.54. If you decide to decrease it and use 0.01 instead of 5% with no other changes to the test, will power increase or decrease? Okay. So this is kind of another way of asking the question in part C, right? This says, okay, to increase power, we increase our significance level. This says we're going to decrease our significant level. What happens to power? Well, power will decrease because the probability we reject the null completely will decrease. Okay? When we lower our significance level, when we lower type 1 here, we are lowering the probability that we not only reject the null incorrectly, but also the probability that we reject it correctly. And that wraps up today's lesson on errors and power in a significance test. Thank you guys so much for following along. And in the next video, we are going to dive into the connection between confidence intervals and significance tests. So make sure to stay tuned for that. As always, if you have liked this video, please click the like button and subscribe to my YouTube channel for more great AP statistics content. I wish you endless success in your statistics journey, and I will see you in the next video.